we're looking at the Maclaurin series for sine x. I had derived this in a previous video. Here, what I want to look at is the graph. Let's look at the graph of this thing. We're going to use GeoGebra. This is GeoGebra. Here, let me put in the sine of x, sine x. Okay, so this is sine x. Can zoom in a bit. Now I'm going to make it thicker so that we can see it. All right, good. Now here, what we're going to do is to plot x as another function. What we have is y equals x. We have the line y equals x. We're going to adjust it as well, and let's change the color. Let's use dark blue. This is the line y equals x. Now let's add the second part of the series to it. Y equals x minus x cubed over what is 3 factorial? 6. So let's see what that looks like. X minus x cubed over 6. So we're going to change this to x minus, my computer keyboard is malfunctioning a bit. So I'll use a virtual keyboard here. X minus, all right, x raised to the power of 3 divided by 6. Now what we want to do is put this in bracket just to make sure. All right, so what does this look like? Oh, you see what x minus x cubed over 6 looks like. All right, let's add x to the 5 over 5 factorial plus x to the 5 over 5 factorial. What is 5 factorial? Let's just get it quickly using our calculator. 5 factorial equal 120. So it's 120. X to the 5 over 120. What does that look like? So we're going to add x to the 5 over 120 to what we have here. So we say this plus, I see that the program, it removed the bracket because they weren't necessary. All right, no problem. Plus x raised to the power of 5 divided by 120. Okay, you see what that looks like. It's joining the original sine x. Now what about if we minus x to the 7 over 7 factorial? What is 7 factorial again? Let's use our calculator to work that out. So we have 7 factorial equal 5040. So this is over 5040. 5040. So we minus x to the 7 over 5040 and see what happens. So this is a minus x raised to the power of 7 over 5040. Okay, this looks a bit smoother. Now, what would be the next term? It would be plus. You notice these are This is really x to the 1 over 1 factorial, you know, which is 1. But we didn't bother to write that. This is plus. So you have x to the 1, 3, 5, 7. This is x to the 9 over 9 factorial. But let's figure out what 9 factorial is. What is 9 factorial? 9 factorial equals big number, 362, 880. 362, 880. So we have 362, 880. So here now, x to the 9 over 362, 880. We're going to add that to what we have here. So plus x to the power, x to the power of 9 over 3. Trying to press the 3 on the laptop itself is not working. 362, 880. Was it that? Let's look back. 362, 880, right? That was it. Okay. You see that? Now, what would have been the next term? Well, you'd have to say minus. And that would give us an x to the 11 over 11 factorial. What is 11 factorial? Let's see. 11 factorial equal. So we have 399,16800. 399,16800. So we have 399,16800. So x to the 11 over that. So we have, it's minus x raised to the power of 11 over, let's just copy and see if we can paste the number there. All right. Okay. So, as you see, it's converging more and more with the sign of x, the original sign x. The next term would be what? It would be plus 11, 12, x to the 13 over 13 factorial. So x to the 13 over 13 factorial. So let's make an adjustment. So we have all of this out here. Plus x to the power of 13 over, now we want to find out what 13 factorial is. 13 factorial equal big number. Let us just copy and paste it. Can't be bothered to be writing all of that and remembering it, all the figures. Alright, okay. Joining it more and more. Then minus x to the 15 over 15 factorial. So we have all of this plus, no, it would be minus x to the power of 15 over, then we have 15 factorial. What is 15 factorial? 15 factorial equal that number there. Okay, it says by 10 to the 12. Number gets really big now. By 10 to the 12. So, what would we have? If we should do this and copy this, let's see if we can copy and write it out as one plain number. Right? So all of this by 10 to the 12. 1, 2, 3, 4, 5, 6, 7, 8, 9. See. So we go. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's the number we have there. So let's add the 10 to the 12 to all of this now. So we're going to minus x to the power of 15 over this number. Okay. All right. So there you go. Oh. So as you can see that as we add more and more terms to it, the series, the power series itself is converging, the graph of the power series is converging onto sine x, right? Increasingly. So there you have that. So that just shows how as you add more and more terms, you get a more accurate value approaching sine x. And the same argument applies to other functions as well.